Hi, my name is Chinmay Pagey. My registration number is 20MI1112, and today we'll be talking about traveling salesman problem. TSP or traveling salesman problem comes under dynamic programming, and it answers the question: given list of cities and distance between each city, what is the shortest possible route that visits each city exactly once and returns to the original city? A brief history about TSP. It was mathematically formulated in 19th century by Irish mathematician W.R. Hamilton and by British mathematician Thomas Kirkman. The general form of TSP was studied in Vienna and at Harvard. It was notably studied by Carl Menger, who gave the obvious brute force algorithm for TSP. Now we are going to understand how TSP works, and we are going to delve more into the theoretical part. Okay, so now let's focus on this very complex looking graph, which is going to be very simplified in a few moments, but let's just understand this for now. So this is an undirected weighted graph which is given. Undirected weighted graphs mean there is no direction between the two vertices, and the edges have some weight to them. Okay, now we need to answer a simple question about: is there any way I can travel through each city with the minimum possible cost? Let's just avoid this, whatever this formula is written, for a few minutes, and let's just understand the problem for now. Is there any way I can travel through all the cities with the minimum cost possible? So the vertices here represent the cities. So I have city A, B, C, D, E, and I have the edges which tell me the cost which it takes to travel from city, let's say A, to city B. Is there any way? This is what TSP answers. So for our convenience, let us say that we start from city A. So city A is our start. We can start from any city, it is our choice, but for now I'll take that we start from city A. So is there any way we can travel from city A to all the cities and end up at A? We have to answer this question. So to simplify this given problem, let us make something which is called as the cost matrix of the given graph. So the cost matrix, what I'm going to do is, the columns of the cost matrix would contain all the city names. In my case it is A, B, C, D, E, and the row would also be the city names. And you'll understand why I'm doing this in a second. So now let's start making the cost matrix. Okay, very simple, nothing very complicated, it's just very logical. Okay, so if I am at A, I'm at city A, and I want to go to city A again, what will it cost me? I'm pretty sure it won't cost me anything because I'm right where I want to be. So the cost, it would cost me zero. From city A to city A, it would cost me nothing. Similarly, from city B to city B, it would cost me, well, nothing. From city C to city C, well, if I'm standing at city C and I want to go to city C, that's what I mean. Not if I'm standing at city A and I want to go to city C. No, this means I'm standing at city C and I want to go to city C. That means it won't cost me anything. So this is 0. The D to D, if I'm standing at city D, want to go to city D, it would cost me 0. And just if I want to I am starting at city E, or I'm standing at city E and I want to go to city E, it would cost me again 0. Okay, so now I see that I've got this diagonal matrix, which is I've got this diagonal. I've got this diagonal which is completely 0. Now what I'm going to do is I'm going to look at the graph. I'm going to understand this graph first. So if I want to go from city A to city B, understand this. If I want to go from city A to city B, what is the cost which I have to pay, or what would be my cost? So we'll look at the graph from city A to city B. This is my cost. 2 would be my cost because I'm going from city A to city B. So my cost would be 2. Okay. Now let's just complete this row first and then we'll move to the next one. Now from city A to city C, what would be my cost? City A to city C, 2. So 2. City A to city D, A to D, it would be 1 as per the question. So 1. City A to city E, it would be 4. So 4. Similarly, we can fill up the second row from city B. So if I want to go from city B to city A, what is my cost? The same as city A to city B, 2. So I'll fill it up as 2. Now if I want to go from city B to city B, city B to city B, 0. And we have already filled this. So city B to city B would be 0. Now city B to city C. City B to city C, 3. This would be 3 as per the given edge. Now city B to city D, this would be 2. City B to city E would be 3. City B to city E. Now let's fill up the next row, which is city C to city A. So city C to city A, which is 2. City C to city B, which is 3. City C to city D, which would be 2, given 2. City C to city E, which would be 2. Similarly, D to A is 1. D to B is 2. D to C is 2. D to D is 0 because we are standing at the same city and we want to go to the same city again. So D to D is 0 and D to E is 4. E to A, 4. This is 2. So, okay. See, E to A is 4. E to B is 3. E to C is 2. E to D is 4. And E to E is 0. So this is what is called the cost matrix for this given graph. So this is the easiest cost matrix. Just to recap, what we have done is from the rows we have taken from this city to this city. This is what we have done. Okay, so now we have come to this formula. This formula looks complex, but trust me, it is very easy. And once you understand this, you will be theoretically able to solve every given traveling salesman problem. Okay, so first, let's understand what this formula means. So what I'm going to do is, let me just bring our original graph and the formula here. Okay, so this formula means G of I comma S. So I would represent the original city which I am starting from, and S would represent the set of cities which I go through. I would represent the city where I start from, and S would represent the cities which I go through. And based on whatever output we get, we will have to take the minimum of all that. C represents the cost, and this J represents the city which we will be seeing this. Okay, so what we need to find right now, just understand this and you will understand the formula as well. So what we need to find right now is we need to find G is represents the graph, and we want to find if we start from city A, we go to city B, city C, city D, city E, what would be my cost? And note, this is not the order which I go to. I could have written this as D, C, B, E, E, D, B, C. This could have been anything. I've just written it in this particular order because it seems nice. So there's no particular order which in this set. All right. So S represents the set and A represents our starting point. So now let us look at the first stage which we are. I'm just going to name this stage 1, and let us understand what stage 1 is going to do. In stage 1, what I'm going to do is I'm going to find the cost of starting from city A, so starting from city A, going to city B and returning, I'm sorry, starting from city B, going through no other cities and returning to city A. This is what I'm going to do. So this means B, what are the cities which I'm going to? S, the set S would always represent the number of cities which I'm actually going to go to. In this case, in the first stage, we are not going to go to any cities. So B to A. Now set S would be null because I'm not going to any cities. I'm just going back to A. Now why we don't write A in the set? Because A would be our starting point. And we are here to measure that only. So we understand this. Now let us look at the cost matrix. The cost matrix is going to be very important in this. Looking at the cost matrix, I hope it's visible. Yes. So looking at the cost matrix, we can see that going to city B, starting from city B, going to no other cities and going to A again is going to cost us 2. So we write 2 here. Now we go to, similarly we go start from city C, go through no other cities and end up at city A. Why I'm emphasizing A again and again is because A is our original start city. We are going to start from A, we are going to go through all other cities and end up at A. So in stage 1 we are finding that if we start from city C, go through no other cities and end up at A, what is going to be our cost? So here we are going to write null as well. We start from C, go to A, our cost is going to be 2, we'll write 2. Now D, start from D, go through no other cities, end up at A. This cost is going to be 1. Start from E, go through no other cities, which is going to be null set. The set would basically represent if we are going through any other cities or no. In this case, in stage 1, we are not going through any other cities. So E, going through no other cities, to A, the cost is going to be 4. So this is stage 1 complete, and we are going to require stage 1 to for further stages. I'll explain how. So this is stage 1. I hope this is clear. Okay, now let's continue with stage 2. And in stage 1 we have not used the formula, but from stage 2 we'll be using the formula, and you'll understand how the formula works and how it is used. Okay, so stage 2, let's take city B, and in the first stage we have seen that we are not going through any cities and directly returning to A. Note this very important point, whatever I am going to do, we are always going to return to A, which is our starting city. Why A? Because it is our starting city. That is the only reason why we are going to return to A. So whatever cost which we write here, it is going to be this, this is the starting city for this case, this is the starting city for this case, not in general. Starting city for this case, we go through all the cities in set S, whichever cities which are right in set S, and end up at A always, which is our starting city. Okay, so let me make that very clear. So in this case, stage 2, let's say we go through city C, the next city which comes. So we go through city C. Going through city C, this is what are going to what our formula is going to do. It is going to measure if we start from city B, go through city C and end up at city A. So our formula, if we see our formula over here, it looks kind of familiar. So I is B over here, the set S contains only C. So let us write this. So we'll take the minimum of the cost of I, B and J. J represents the elements in the set. So in this case, there's only one element in the set. If there are multiple elements, we'll look at it in the we'll look at it further. So B, J is C plus G of J is going to be C, and the set which is given is C minus J, and J we know is C. So this is going to be what we are this is what we are going to use. Let us simply evaluate this. So the cost from C to BC is going to be 3, as we can see from our cost matrix. The cost from B to C is 3. Cost from C to D is going to be, whenever C is written, that means we are going to refer to the cost matrix. And now we can see this is G of C minus C. The set C minus C is always going to give us null set. So any set minus any other set which contains the same element, it's going to give us the null set. So 3 plus G C comma a null. This looks a bit familiar. This is what we calculated in stage 1. So here we can see this is 2. So C comma null is equals to 2. I'm just going to write 2 here, and this is going to give us 5. Now I'll write minimum of 5 over here, but there's no point of writing minimum of 5 because the 5 is the only element present here. However, if there were more elements present, we would have taken the minimum of all that. I'll be explaining this further in the video. So this would be equal to 5. Similarly, now we have to do this for all the remaining elements. So now we'll go from G to B, and what if it only travels to D? What if? So we'll take minimum of CBD plus G of D. Why have we taken D over here? Because according to the formula, J is this element which we have taken, and D is the element. So this D minus D. So this is what, so the cost of BD according to the cost matrix is cost of BD, B to D according to the cost matrix is 2. So we are going to write 2 over here. So the minimum of 2 plus G of D comma null, and yeah, this is going, okay, it's fine. So D comma null, minimum of 2 plus, this is what we found in stage 1, which is going to be 1. So this is going to be minimum of 3, or we can simply write 3. I'm not going to write minimum further because it's understood that this is the only element which is possible. Now we have one more point which is left. This is going to be G of B comma E. E is the point which we are going through. We are not going to go through C, D. We have gone through that in the previous one which we have solved. Now we are going to go through E. So minimum of C to BE. Again I am repeating, C means you will refer to the cost matrix. E comma E minus E. The C to BE cost matrix shows us B to E would be 3. So we will write 3 over here, and this would give us E comma null set, and E comma null, we have found out that E comma null would be 4. So this will be 3 plus 4, which will give us 7. Now stage 2 is going to be a bit long because this is the longest of all stages, but once you go through this, it will be a breeze forward, and this is one of the most important stages because it's important for the upcoming stages which we are going to see. So just bear with me over here. So C, CB plus G. I'm just going to write B comma null over here. I hope you understand how we got null over here, because we subtracted B which was the set from the original set. Alright, so, the cost of CB, I've been referring the cost matrix again and again. So this is going to be C to B. The cost of C to B is 3, and this given value here is 4. I'm sorry, this given value here is 2. So this is going to be 5. Now G of C, so as you can see, we have to do it with all the possible we have to do all the possible combinations. So now B to D, now B to D equal minimum, C to CD plus G to D comma this, which is ultimately going to give us 2 plus this is cost of 2 plus this value is 1, which is going to give us 3. G of C comma E equal minimum C CE plus G E comma null. This is going to give us 2 plus 4, referring this from the cost matrix, referring this from stage 1. It is going to give us 6. And I'm just going to write all the values now. I hope you have understood how to calculate these values, so I'm just going to write it without the formula. If there is any doubt, you can refer back to the formula which was given. So this is going to be 2 plus 2, this is going to be 4 again. This is going to be D comma E. 3 plus 2, 5, G comma E, G of E comma C. So these are the values which would be there for stage 2, and these would be crucial for the next stages. Now we are going to go to stage 3. Stage 3 means that we are going to refer to a point, we are going to take a point, and we are going to travel through 2 points. That means we are going to start from B, travel to through 2 points, which is C and D, and end up at point A, which was the starting point. Okay, now just focus a bit and you'll understand this. So let's divide this into two parts. The first part we would see from B to C, and the second part we would see from B to D. So let's take this like the minimum, or forget the minimum, we'll just go from here, C to BC plus G to, okay, I'll explain this further, and this would be C to BD plus G of this, whatever this is, I'm going to explain it now. Okay, so what our formula says, let's just refer to our formula for once and then we'll proceed. So our formula says cost of ij, here I have taken I as B, in this case I have taken I equals to B and J equals to C. In this case I have taken I equal B, J equals C. This part is right. Now focus on this part. What does this part say? J, what is my J over here? C. So I'll write C. Okay. Now S. What does S mean? S means the set present over here. The set present over here meaning this set. So I'll write this set. I hope this is visible. So this is C comma D, set is C comma D, minus 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 J. If you understand this, you'll understand TSP. TSP is very easy. So minus J. J here is C. So minus the set which contains the element C. So C comma D minus the element which contains minus the set which contains element C. So if I write it further, if I write this point further, C BC plus G C comma D minus C. Okay, CBC is we can take CBC from our cost matrix. So I'm just going to refer the cost matrix for now. Cost matrix shows C, the cost of C from B to C to be as 3. So this is going to be 3, and this is going to be, if we subtract C from the set CD, what are we going to be left with? We are going to be left with a set which contains element D. This is key. You see, now we know the value for this. How do we know the value for this? From stage 2. Because in stage 2, we calculated the value for this. So now this value is going to be useful here. So here we take 3 plus G of C comma D is 3. So we take 3, which is going to give us 6. Similarly over here, G of D, here we have taken I equals to B and J equals to D. So here D comma C comma D, which is our set, minus D. Why minus D? Why this? Why is it minus D over here and why is it minus C over here? Because here J was C and here J is D. That is why we take D. Here also we have written D. So here if we say, if we understand this, this is going to be CBD plus G of D, comma, subtracting element D from set which contains CD. Subtracting the set D, the set which contains D from the set which contains CD, we are going to get a set which only contains C. CD, and the cost for this is going to be 2. The cost for this D comma C is going to be 4. How do we know that this is 4? We have calculated it in stage 2. So we know that this is 4 because we have calculated this value in stage 2 already. So this is going to be 4 plus 2, 8. 4 plus 2, this is going to be 6. So now we'll understand why we write minimum always. So now we have to take the minimum value of these two values obtained. So minimum of 6 comma 6 is equals to 6, because there is no minimum, we can take any of the values. So we take 6 over here. So this is how stage 3 is going to be. So now to understand, so we are obviously not going to write it like that, we are going to write it in a more proper manner. So we are going to take C2E C2E equals to the minimum of CBC plus GC comma CE, this given set, minus minus C, because in this case I is B and J is C, and C comma B E plus G E comma C. I've written it directly over here. I hope you guys Uh, I hope you guys understand this. So why I've written C over here, because this is the result which we get when we subtract the set CE with we subtract the set which contains E from the set which contains CE, which was this original set. So now we get the value. Let's calculate this. CBC from the cost matrix, we know it is 3. This value, this, okay, so this would give me this, this would give me E, comma CBE. Okay, so let's just do this first. 3 plus, we know this value because of stage 2. So in stage 2, this value was 3. We know this value, and now we're going to do this. So CBE value from the cost matrix is 3, and this value from stage 2 is 4. So we've understood this now. So 3 plus 4 equals to the minimum of 6 plus, okay, I'm sorry, so this value was 6. This value is 6. This is going to be 9, 4, 5, 6, 7. So this is going to be 7. And now we take the minimum value. That is why we always write minimum over here, because we are going to take the minimum value of these two. We are not going to take both of them. We are going to take the minimum value. So this is 7. This is the minimum value. I hope you understand why we write minimum now. So similarly, we are going to calculate all of them. So we are going to do G of, I'm just going to calculate all of them just without writing all this stuff so that we save time. So this is going to be the minimum. You can calculate this on your own and verify this answer afterwards. So 3 plus 5 equals to, so minimum, so we get 10, and we get 8. So this is going to be 8. I've already calculated these values, so I'm just going to write it directly. You guys can calculate and see what value you get. So equals to a minimum of 6 comma 6, which would give you 6. G of C comma B would give you it would be minimums between 10 and 7, which will ultimately give you 7. G of C comma D, just make sure you go through every possible combination over here so that you don't miss out on anyone. So you go from minimum to 10, 7, and the minimum which you get. G of D comma DC, 7 comma 7, which is 7. D comma BA, no, 9 comma 9, 9. G of DCE, minimum of 8 comma 8, which is going to give us 8. This will take a bit long, but it would be easy if you just calculate root. Fine. B comma C. This was minimum of 8 comma 7, and that's how 7 came over here. This would be between the minimums of 5 comma 8, and we would get 5. This would be the minimums between B comma D, and between those the minimum would be 6. So this is stage 2 complete. Just calculate every value and tally it with this, and now we move on to stage 4, the last stage. Okay, Stage 4, the last stage of this long traveling salesman problem. And now we are getting to the final parts of it. And this is, as you can see, the stage 2 was the longest. After that, stage 3 got a bit shorter. And then now stage 4 is going to be the shortest of all. Okay, so now G of, we are going to start with B. And now what we are going to do is we are going to go through every possible node apart from A. So we are going to go through C, we are going to go through D, go through E, and we are going, so we are going to go through all these nodes. Just using the previous formula, which is told in the previous parts of the video, we will get the value. Okay, I'll just explain this once. I'll do it for one and the rest of it can be understood. So okay, so looking at the formula once again, this is the formula. This is the formula which we were looking at, and this says that cost of ij, in the first case we'll take j as c. So in this case we'll take c as c of bc plus g of j. J is going to be c over here because in this we have taken I equals to b and j equals to c. So j is going to be c over here, and s is going to be this set. Just don't confuse s with any other set. It is going to be this set. So it is going to be c comma d comma e minus what? Minus only j. So j here is c minus c. So we get cbc. We're going to go calculate this plus j of c comma c taken from this set. Element c taken from this set is going to leave it with de. This we have calculated in stage 3. So you can refer the value for this in stage 3. The value for this was 7, and this value cbc can be looked up from the cost matrix, which was 3. It would give us a total of 10. Similarly, we have to do this for C, BD and CBE, and if we use the same formula for this, and the final value which you will get, a minimums between 10. There is a value for CBC. This is not the value for CBC. So by CBD I mean you have to after this you have to take BD and then BE. This is not exactly the cost matrix only. You have to take it, that use this formula and find out the value for BD and BE. Okay, so this would be for BC. This is the you'll get the value, if you calculate you'll get the value 10, which would be for BD, and you'll get the value for BE, which would be 8. So the minimum of this would be 8. Similarly, just apply that same formula over there and you will get the answer. Now you'll take the point C. You'll go through all the other points, and you'll have to find out the minimum between 11 and 8, which the minimum would be 8, and this would be D. So it would be C comma B comma C comma E. The order doesn't matter because ultimately you're going to get the same thing. So B comma C comma, so you're going to get a minimum between 9, 9 and 11, and here you can choose any of the 9s, that doesn't matter. And lastly you're going to get G of E comma, you're going to find out these values, which is going to be the minimum of 9, 8 and 11. The minimum of this is 8. So this was the final stage, and now we are going to go directly to the answer, how to find the final answer. Answer. Finally, we are going to get the answer for the traveling salesman problem. To obtain the answer for traveling salesman problem, we'll just use the given formula once, where now the starting point would be A and we would go through all points between B, C, D and E. We're going to go through all points. Now we will apply the same formula which was given in the last one, which we have been discussing in the whole video, and through this we will obtain the minimum points, which are going to be 10, 10, 10 and 12. Simply just use the formula, use the set method which was in the end of the formula, and you'll be able to solve it. I'll just show one example of this. So let's say we have to take g of a and b. So in this, the first case which we will take is c of ab, comma, uh, yeah, okay. We are going to take c of ab. Here it's going to be g of, in this case I is a and j is b. So here b will come. So b, comma, the set, which is the whole set. So b, c, d, e, minus what? Minus j set, the j values. So b. So this would be c a b plus g b, comma, b subtracted from this set would give us only c, comma, d, comma, e, and we know this value because we have calculated this value in stage 4. So finally we are going, and we can find this value from the Koch matrix. So c a comma b is 3, and this value from the matrix we have from the stage 4 we have found is 6. Let me just once again explain so that there are no confusions. This is the value which we are talking about. The value for this B, C, D, E, and the minimum value for this we found is, oh wait, this is 8 and this is 2. Sorry. This is the cost is 2 and the value is 8. Okay. So this is the value which we are talking about. So this minimum value which we got is 8 and the cost matrix value is 10. So this 10. Similarly, you can do this. You have to do this for C, A, D. C. You have to do this for AC, AD, AE, and you end up with 10, 10, 10, and 12. Now, minimum value of all this is 10. So now the question arises: what is the path? The path is really simple to find, and it can be found by the stages which we have found. Okay. So obviously we are starting from A. A is our starting point, so the starting would be A. Now from A, where do we go? This question is answered by stage 4. Now if we look at stage 4, we see one of the values being 10, one of the values being 8, another value being 8, another value being 9, another value being 8. In this, simply take the minimum value. I repeat, take the minimum value. So if you look at it, the minimum value is, so 10 is not into consideration. This was from the calculations. Okay, so in the only values which are taken into consideration are 8, 9, 8, 8, 9, 8, 8, 8, 9, 8. So now 8, 8, 9, 8, take the minimum value. Which is the minimum value? You can take any value of 8, because you cannot take 9, it is not minimum. You can take any value of 8. Let's say I take this value of 8, this value. You can take this, you can take this. Okay, so I take this value. What is the I of this value? What I mean by I is, when I use this formula to find out this value, what was my I? My I was B. So whichever value I take, I need to look at the I of it. And I need to write that I over here. For example, if I had taken this 8 value, if I had taken this 8 value, this 8 values I was C. So instead of B, I would have written C over here. Okay. Alright. So now B. So now from B, where do we go? For that, we need to refer to stage 3. Now stage 3. Stage 3, we have the value for this, which is 6. We have the value for this, which is 7. We have the value for this, which is 8, 6, 7, 7, 7, 7, 9, 8. The value for this, which is 7, 5, 6. Which is the minimum value out of all this? The minimum value out of all this, if you look at it, also if you have done the working, 6, 7, 8, 6, 7, 7, 7, 9, 8, 7, 5, 6, 5. 5 is the minimum value which I get in stage 3 after doing all the calculations. 5 corresponds to which I value? 5 corresponds to E. Again, I found out 5 when my I value was E. This is what I mean by it corresponds. I found out 5 when my value was E and I was going through nodes, I was going through vertices C and D. So E. So I'll write E over here. So for the next node or for the next edge which we are going to go, we have to refer the stage 2. Now in the stage 2, we need to look at the minimum value of all the things which we have calculated. So in this case, we see the value 5, 3, 7, 5, 3, 6, 4, 4, 8, 5, 4, 5. Which is the minimum value I see? I see 3 as my minimum value. So 3 corresponds to which I? 3 corresponds to B. This is a problem now. Because if I write B again over here, if I write A, B, E, B, my salesman would go back to B again, which I don't want. I don't want my salesman to go to a edge with, go to a vertex which it has already visited. I don't want that. So my salesman would go to B, which I don't want. So I would eliminate all the i's which are B over here. So I won't consider this, I won't consider this, and I won't consider this because it has B as its I. It has B as its I. Alright, so now I'll move on to the next best thing, which is the remaining ones. C, 5, 3, 6, 4, 4, 8, 5, 4, 5. These are the only ones. I would also not consider E because of the same reason, because it has already gone to E. So that won't make sense. I won't consider E. So I am only left to find the minimum between I's which are C and D. So here I have 5, 3, 6, 4, 4, 8. Which is the minimum in this case? In this case, the minimum is 3. This 3. So the minimum is 3 and it corresponds to C value. So I would write this as C. Now for the final part, I would go to stage 1. Final part, I would go to stage 1, but also if you don't want to go to stage 1, it seems completely logical because the only left vertex is D here, so we can only go to D, but let us also verify from stage 1. Stage 1, the minimum value is 1 and it corresponds to vertex D. So it goes to D and D back to A. You have to write this because it is very important. It goes back to A because the salesman travels from all the vertices, from the starting vertex to all vertices back to A. So this would be the final path which the salesman takes, and total cost of this would be